Radian measure. 1 radian is the measure of the central angle of a circle, subtended by an arc equal in length to the radius of the circle. So we've got a circle with a center at 0, 0, and we've got a radius r, which is the length from the center of the circle to a point on the outside of the circle. So let's call that point A. So what we'll do is the length of r, if you were to curve that and wrap it around the outside of the circle, and it would end about here, according to the look of my picture. So this radius r is the same length as if I were to curve it around the circle. And so whatever angle that makes is 1 radian. And I'm going to call that alpha. So alpha here is 1 radian. Because the angle cuts off an arc of equal length to the radius. Now let's say I wanted 2 radians, so then it's going to be that same red length but twice. So then that's going to take me to about here if I do the length of the radius a second time. So now that angle, let's call that rotation beta. So beta in this picture is 2 radians. Again, we're starting at the initial side. 2 radians because it's 2 of the radius put together. Let's say I wanted 3. I think you're getting the idea. We want that same length again. So whatever angle that would make, so that's 3 radiuses on the outside. That rotation, let's call that gamma. So then gamma is 3 radians. And then let's say we want to go all the way around the circle. If I want to go full circle, then that would be the total length of the outside of the circle, which is called the circumference. Circumference. So remember, the circumference of a circle is 2 pi r. 2 pi r. And then we're saying that we already said earlier that is 360 degrees. 360 degrees. Now, if we do the radius once, it's 1 radian. If we do it twice, it's 2 radians. 3 is 3 radians, or 3 r's. So this is 2 pi r's, or 2 pi radiuses. So 360 is 2 pi radians. So let me call that, well, we're just going to say 360 degrees is equivalent to 2 pi radians, which is approximately, in decimal form, 6.28. So now let's talk about the 2 different measurements, radians and degrees. So radians, it's either going to say radians or it's going to have no symbol up in the corner. So it's just going to say like 2 pi. For degrees, it'll either say degrees or it's going to have that degree symbol in the top right-hand corner. So anytime we see that little circle, it means degrees, and if there isn't one, it's in radian form. Now, this is your conversion factor. 2 pi radians is equal to 360 degrees. We can actually simplify this by dividing both sides by 2. So we can take our conversion factor to pi radians is the same thing as 180 degrees. So this is your conversion factor that you're going to use to convert between the 2 forms. So let's use it. Let's say I want to know what is 150 degrees in radians. So just like in chemistry, you're going to do some dimensional analysis. You're going to multiply by 180 degrees on the bottom, and you're going to put pi radians on the top. So why do we put degrees on the bottom? Because that is going to cancel your units for degrees, and it's going to leave you with radians. Then you just reduce. So 150 and 180, that reduces to, we can take out 30 degrees out of each of those, or we can divide the top and bottom by 30. That's going to give me 5 and a pi on top, and that's going to leave me with a 6 on the bottom. So 150 degrees is equivalent to 5 pi over 6 radians. Let's try that again with a different measurement. Let's try 225 degrees. So I'm going to put degrees on the bottom again so that I can cancel my degree units. So that is going to cancel degrees and leave me with radians. 225 and 180. 45 goes into each of those numbers. 225 divided by 45 is 5. And I also have a pi up there. And then 180 divided by 45 is 4. So 5 pi over 4 is the radian measure. Let's go the other way. So let's say I start with 7 pi over 4 radians. I know it's in radians because there's no degree symbol. So that means I'm going to want radians on the bottom of my conversion factor. So right now there's an invisible radians. It doesn't have to say it. And I'm going to put degrees on top because I'm canceling the radians on top and on bottom, leaving me with degrees. So I'm going to do, also your pi's cancel out. So you're going to have 180 multiplied by 7 and then divided by 4, which gives you 315. So 315 degrees. So let's do the same thing for pi over 3. There's no units, so these must be radians, which means I'm going to put radians on the bottom to cancel the radians. And I'm going to put degrees on top to keep degrees. Radians cancel, pi's cancel. So I'm left with just 180 degrees divided by 3, which is 60 degrees. And so that is how you're going to convert.